MiG-35 is a new export variant that combines the modern systems of the MiG-29M2 with an AESA radar and manufactured by Mikoyan. The fighter plane has the thrust vectoring of the MiG-29OVD as an additional option. Improved avionics and weapon systems, notably the new AESA radar and the uniquely designed optical locator system, OLS, make the aircraft less dependent on ground-controlled interception (GCI) systems and enables the MiG-35 to conduct independent multirole missions. MiG-35 is compatible with Russian and foreign origin weapons applications and an integrated variety of defensive systems to increase combat survivability. The fighter plane is being marketed globally under the designation MiG-35, single seat, and MiG-35D, dual seat. MiG Corporation made their first official international MiG-35 presentation during Aero India 2007. MiG-35 Fulcrum-F is an export version of the MiG-29MOVD. Fulcrum-F, MiG-35 development. The final version of MiG-35 was displayed for the first time at Aero India 2007. The prototype of the MiG-35 had been shown to the public in 2005 at air shows in Russia and the UK. MiG-35 is a contender to the Eurofighter Typhoon, F/A-18E/F Super Hornet, Das Ultrafale, JAS-39 Gripen, and F-16 Falcon for the bid of more than 126 multi-role combat aircraft worth $10 billion to be procured by the Indian Air Force and Indian Marsa competition. Mikoyan will commence production of the MiG-35 fighter at the Sokol aviation plant in Russia in 2013 or 2014 as part of the bid. The export version aircraft was demonstrated to the Russian President, Vladimir Putin, at MAX 2019 Air Show in August 2019. In June 2019, Russian Aerospace Forces received delivery of first two MiG-35 fighter jets. MiG-35 AESA radar. MiG-35 is the first Russian aircraft to be fitted with active electronically scan array radar. The JCAM's antenna consists of 160 modules, each with 4 receive and transmit modules. It is believed to offer a 160 km (85 nm) air target detection radius and 300 km for surface ships. Like radar, OLS allows the MiG-35 to detect targets and aim weapon systems. But, unlike radar, OLS has no emissions, meaning it cannot be detected. OLS works like a human eye by getting the picture and later analyzing it. NIIPP, the Federal Space Agency Science and Research Institute's engineers have chosen more short-wave bands for the matrix, which has increased sensitivity of the complex several times and has increased detection range. The OLS on a MiG-35 is considered to help pilots to spot even the USAF stealth planes. OLS includes a complex of powerful optics with IR vision that makes it impossible for any plane to hide. OLS solves the problem of blurred vision. At speed, each piece of dust can cause harm to the glass of the OLS. The new OLS uses Leuco sapphire, the next hardest material after artificial diamonds, making the lifetime for such glass much longer. According to NIIPP engineers, Leuco sapphire is clear for all the OLS emissions and doesn't corrupt the signal, an important factor for the optical systems. MiG-35 engines. The MiG-35 is powered by 2 RD-33 MKBs that can be fitted with Cliff swivel nozzles and a thrust vectoring control (TVC) system. The MiG-35's combination of TVC and advanced missile warning sensors gives it the edge during combat. RD-33 engines generate 7% more power compared to the baseline model due to the modern materials that go into the manufacturing of the cold blades. The engines provide a higher than average thrust of 9.0 kgf. RD-33 engines are smokeless and include systems that reduce infrared and optical visibility. The engines may be fitted with vectored thrust nozzles, which would result in an improvement in combat efficiency. Russia's developmental work on thrust vectoring started in the 1980s. The Sukhoi and Saturn/Lilka engine design bureaus led the way, and their efforts resulted in the Su-30 MKI aircraft. The MiG and Klimov engine bureaus began their work in the field of thrust vector engines a little later and aimed at all-aspect thrust vectoring, as opposed to Sukhoi/Saturn's two-dimensional, horizontal/vertical vectoring. Klimov achieved the last-spec vectoring with the aid of 3 hydraulic actuators that deflect the nozzles and are mounted at 128-degree intervals around the engine nacelle. This enabled MiG-35 to fly at very low speeds without angle of attack limitations, and ensured that it will also remain controllable in zero speed and negative speed, tail forward, areas for sustained periods. Maneuverability. The MiG-35 is a highly maneuverable air superiority fighter, which was shown for the first time in August 2005 during the MAX Air Show outside Moscow. The fighter is powered by RD-33OVD thrust vectoring control engines. The RD-33OVD engines provide superior maneuverability and enhance the fighter's performance in close air-to-air engagements. The MiG-35 presents supermaneuverability, a capability to fly at supercritical angles of attack at increased level of sustained and available G-loads and high turn angle rate, which requires a greater thrust-to-weight ratio and improved wing aerodynamic efficiency. MiG-35 weapons. The aircraft's suite of guided weapons includes KH-31A anti-ship missiles with active radar seekers, the KH-31P anti-radar missiles, KH-29T missiles, and KA-B500 KRDV guided bombs. Added, when equipped with an external optical/laser targeting pod, the fighter can use the K-29-liter air-to-surface missiles and K-500-liter laser-guided bombs. These weapons will allow the aircraft to engage aerial and land targets. Italy-based Elettronica signed an agreement with Mikoyan in 2007 to support and incorporating the LT/568 V2 self-protection jammer in the MiG-35. The jammer renders self-defense from radar-controlled anti-aircraft artillery. In addition of a strap-on tank behind a cockpit, has allowed MiG-35 to have a higher internal fuel capacity of 950 L. The capacity of the external fuel tank suspended under the fuselage has increased up to 20 L. Ferry range with 3 external fuel tanks has also been increased, rising to 3,100 kilometers, and with 1 in-flight refueling, the range will be 5,400 kilometers. The fuel management system has also been digitized and includes a new digital fuel metering system. Performance. The MiG-35 can climb at the rate of 330 meters per second. Its maximum speed is 2,400 kilometers per hour. The normal and ferry range of the aircraft are 2,000 kilometers and 3,100 kilometers respectively. The service ceiling is 17,500 meters. The aircraft weighs around 11,000 kilograms and its maximum takeoff weight is 29,700 kilograms.